Firstly, I want to introduce myself. I'm Elham SATARI. I've got my master degree in Iran in 2014. After that, I was research assistant in Iran for 4 years. I've started my degree at Polytechnic in January 2020. My supervisor is Sebastian Leclerc. He is research assistant in Polytechnic. His research area involves several categories. We use the lattice Boltzmann for following reasons. My thesis will be about modeling turbulence multi-phase flows with lattice Boltzmann method. Firstly, lattice Boltzmann education is completely linear, whereas the conventional Navier-Stokes are non-linear. Second, three boundary conditions in lattice Boltzmann are formulated easily with using elementary mechanical laws such as bounce back at wall. Since lattice Boltzmann is an explicit stream, locally interaction, lattice Boltzmann method is ideal for parallel computing. Last but not least, LBM is mesoscale in nature. It means that it can capture many interfacial phenomena which are in mesoscale or macroscale in nature. Let me explain this in next page. It can be seen that more fundamental approaches are particle-based, i.e., molecular cluster-based. Discrete methods such as molecular dynamic, direct simulation, and dissipative particle dynamics. The high computational of these methods make them impractical. On the other hand, continuum-based approach ranging from DNS to Euler are in macroscopic and couldn't capture mesoscale or microscale phenomena. The lattice Boltzmann method sitting in the middle of the figure is a mesoscopic approach which help lattice Boltzmann method to use macroscopic or mesoscopic physics while covering the macroscopic laws and properties and affordable computational cost. So it's a promising tool and method for modeling phase change phenomena which are in meso and macroscale in nature, such as boiling, condensation, cavitation, interfacial dynamic generally. As a mechanical engineer, I've always been interested on some complicated phenomena happened in nature, having impact on people's life. After considerable research, we choose turbulence multi-phase flow because firstly it's in fact a cutting edge phenomena. It's also complicated phenomena and many aspects of it are still unknown, and it's a real life application. Thank you for your time and attention.